So, following on from our PL session last Wednesday and looking at computational thinking and how that thinking can inform the design of an algorithm, I thought I'd add just another example just to support the thinking that had begun and to share some of the thinking. So, we've got our flowchart symbols to the left here. What I've added to the top here is just to identify what's the data that I'm relying on to build this algorithm? What's the problem I'm trying to solve? Who will the solution be implemented by? If it's implemented by a computer, it would look slightly different to here because a computer isn't as great as interpreting abstract instructions like we are. What I've also included is some key data or parts of the problem. So I'm going to introduce in this example the concept of variables. And just to reiterate, we looked at decisions or branching last Wednesday. So let's begin. Here's a milkshake I'm making. Um, the decisions I've included in this algorithm are flavor selection and flavor strength. And the variables that I've included within this algorithm are flavor and no, not ignore size. I was going to look at size. This could be part of the design process because I was initially looking at size and then I thought, no, I'm just going to create a set size. So to begin, I'm going to pour 370 mils of milk into a glass. The first decision is, will this be a traditional or custom milkshake flavor? So if it's going to be a custom milkshake flavor, I'm going to follow this decision to the left. And here you can see flavor equals. So the flavor is a variable. And when you see an equals, this is where we're going to be assigning a value to this variable called flavor. You'll notice that there's a parallelogram here, which means it's requiring input. So let's just say the input, if I was going down the custom route, I'm going to make a banana milkshake. So when we see the word flavor throughout the algorithm, we know the flavor equals banana. Moving back to the prior decision, will this be traditional custom milkshake flavor? If we're going the traditional route, what I've included are just the traditional uses of the decisions that you see within a flow chart. And this is very similar to how a computer will interpret these decisions. It can either be true or false or binary on and off. So, traditional flavor, chocolate, no. Strawberry, let's just say for this example, yes, it's going to be a strawberry. Then the flavor, which is the variable, will then be assigned strawberry. So we'll follow the logic lines here in the flowchart, and we're going to come to another decision. Will this be a standard or strong flavored milkshake? Here's another decision. We're going to make a strong milkshake. To complete this part, add 2 teaspoons of flavor. Now remember, flavor is a variable that we've assigned as strawberry. So add 2 teaspoons of strawberry flavor to a glass. Stir the milkshake, then taste. Is the flavor strong enough? Now if the answer is no, we're going to follow this line. Now this is a loop. And every time we run through this loop, we call that an iteration. Add 2 teaspoons of flavor to the glass again. Stir the milkshake, then taste. Is this flavor strong enough? Yes, it is. You've now completed Chris's milkshake making algorithm. So I just thought I'd just demystify some of the questions that we have because I know how difficult it can be when first looking at symbols that you would see within a traditional flowchart or in this scenario using the flowchart to create an algorithm. So I hope this helps. If you have any questions, please don't hesitate to contact. Thanks for watching.